Thank you very much. Thank you very much for being here. I know it's tough. I know it's just after lunch. And how about we just don't do slides and go for a siesta instead? That would be lovely, right? Yeah, I would love that too. So yeah, I'm really happy to be here. My name is Marcus. I'm a developer evangelist for Twilio. Does anyone here not know Twilio? Can I just have a show of hands if you don't know Twilio? So Twilio is a communications API that makes it easy for you, the developers, to add text messages and voice and video now into your applications. So, but today, I'm really not here to talk about Twilio. I feel like my talk is almost like an extension of Daniel's talk. So Daniel, the guy before me, he was talking about patterns on APIs, and one of the things he actually touched on was enterprise queuing, so like communication between APIs. So my talk is basically about how APIs can actually communicate, okay? So I'm going to start with why queue, right? So the first thing here is everybody hates queues, okay? So no one really does anyone here like standing on a queue? That guy, cool. So yeah, no one likes queues except for the British. The British love queues, and 2 weeks ago, I was in Berlin, and I asked, does anyone like queue? And maybe like half the room said, yeah, I do. And I was like, okay, so I'm gonna have to change my slides. So the Germans also love queues, and now are you guys from Spain? Okay, so I'm gonna have to add Spain as well, because apparently Spanish people also like queues. Now, what is a queue? So why would you use a queue? So a queue is a semantically precise message. So a queue is a place where you can put your messages, so you can have multiple systems talking and adding messages into one queue. So you're talking about semantically precise messages, and you're talking about decoupling. So you're talking about having multiple systems that are completely decoupled from each other, that don't rely on each other, and they can still communicate regardless of languages or regardless of anything you're using. There should be really, really low impact on using queues. So if you have two systems talking to each other through a queue, there should be no impact. So if anything was to happen, if one of the systems was to die, for example, there should be no impact. Your system should continue going. But I'm going to give you an example here, okay? So I have two cats on the screen, right? So the first cat goes meow, and the second cat goes meow. So two cats talking to each other, great. Let's use dogs. So the first dog goes woof, and obviously the other dog is Brian. So Brian doesn't go woof, he goes oh hi. But they're still dogs, so they're still talking, okay? Now, next example, and I'm going to need your help on this. I have Java and I have JavaScript here. If Java goes email.sendMessage, what will happen? Can anyone take a guess on what will happen here? Well, JavaScript will go, what? So you have two things there trying to talk to each other, but they don't speak the same language. And very soon, you have an error just like this on your system, right? So that's because Java is to JavaScript as car is to carpet, right? So Java is one thing, JavaScript is another thing. And really, I'm using Java and JavaScript here because I'm being picky. This could be anything else. This could be Ruby, this could be Python. They just don't talk to each other naturally, okay? So that's how snob they are. How about we go back to this example? So how about we go back to Java and JavaScript and try to find a way so they can actually communicate, okay? So we tried this first. So we tried email.sendMessage. That didn't really work, okay? So that broke everything. How about we try a semantically precise message? How about we get Java to actually send some JSON to JavaScript? Well, that will work because it's JSON. Pretty much every single language can speak JSON in a way. However, Java can't really communicate to JavaScript directly. And then again, I'm really being picky on Java and JavaScript here. This could be anything else. So what we need to do to actually get those two to talk is we need to introduce a queue. So a queue is an easy way for you to add and read messages off. So think of it as a proxy. Think of it as, okay, so I need to communicate from A to B, but there's a proxy in the middle. So that's your queue. So the way you would get your queues to communicate, your applications to communicate is you add the message to the queue, and whenever, in this case, whenever JavaScript is ready, JavaScript goes, hey, I'm taking that from the queue. So they are talking the same language. They are communicating using AMQP. Think of AMQP as HTTP. So it's just another protocol, but it's the protocol used by queues. So it's the protocol you use to actually get your queues to communicate with your applications, or your applications to communicate to the queue. Cool. So now I'm going to talk to you a bit about traffic shaping, because traffic shaping is something very important in my opinion. How many times have you had a system crash or something because too many people came into your application and they basically just broke it? It's a problem when you have a single application. Even if you have microservices, if your microservices aren't really communicating, or if you don't really have a way to get your microservices to communicate, then traffic will become a problem. But guess what? Traffic is a good thing. Traffic is not a bad thing. So with enterprise queues, what you can do is you can have as many instances of your applications as you want, and you can get those instances publishing or reading off a queue. Queue being your, whatever you decide to use for a queue. My next point here is scalability, okay? So you need to make sure that your applications scale. Nowadays, if you have an application that doesn't, well, you shouldn't even be a developer if you're not thinking about scalability. So you want to make sure your applications scale. The other thing about using queues is scaling applications is very, very easy because, like I said, you can have as many applications or as many instances as you want of your application, and you can just use your queues to communicate between your applications. So there's no need to have a single instance and having those applications talking via HTTP, for example. So scalability is very important, and your apps should scale. Your APIs should be able to scale. You should be able to spin up as many versions of your API as you want, and it should still scale. I know some talks today talked about how to scale APIs. There's some great people outside as well talking about helping you scaling your APIs. The next thing is isolation, okay? So when you're using queues, especially when you're using microservices, you want to make sure that you are isolating your apps. So you want to make sure that your apps don't really rely on anything else. You want to make sure your apps are completely out there. They have their own box. If you're using Docker, you can have a container for this. But you want to make sure your applications are completely isolated. But if you isolate, how are you going to communicate? Well, guess what? Queues will help you communicate. Queues will give you the communication back, even if your apps are isolated. So it will also keep your errors away, because if your apps are isolated, if there's an error going on in one of the apps, it won't really affect anything, because, again, your apps are talking via a queue. So there's a proxy in the middle. There's something in the middle that is just taking care of this communication for you. Cross-platform is something, I'm a developer myself, and I like coding, regardless of the language, regardless of what tools I'm using or frameworks. I like coding, okay? So I've spoken to many developers in the past who said, well, yeah, I'm working for this company, and all they use is .NET. So now I need to build systems in .NET, even though I know they're not going to be very good. Well, yes, if you are in a .NET world and you want to build other apps and you want those apps to communicate in an old-fashioned way, you would just stick to the same language. So if it's a Java shop, stick to Java. If it's a .NET shop, stick to .NET. With queues, you're kind of taking this away, okay? Because communication is no longer a problem. You can use whatever you want. So I think using the best tool for the job is the message here. So you can use any tools. As long as you can communicate between those tools, you can use anything you want. Now, this slide is very particularly dense, so stay with me. I know it's after lunch, but stay with me. So the way a queue actually works is you have a producer, and you have a message bus. So the message bus is where your messages actually go, and obviously your producer is the thing that actually generates the message. So this could be your front-end application, for example. So your producer goes, hey, I want to send emails, or I want to get some currency exchange, or I just want to doctor an image, so I just want to go and change an image or resize and upload the image. The way you get your application to communicate with the queue is you generate a set of semantic messages. So you generate a set of JSON messages that will have information about emails, that will have information about what sorts of currency conversion you want, and you just push those messages into the queue, right? Once you have those messages into the queue, your application is basically free of anything. Your application is not waiting for a response. This is a fire and forget thing. So you're just passing the messages on, and you're saying, hey, deal with it as best as you can. Then that's where the microservices come. So I have 3 new characters here. One of them is Mr. Postman, the other one is Mrs. Banker, and the other one is the doctor, right? So Mr. Postman is very good at dealing with messages. So email messages, SMS messages, you name it, Mr. Postman will deal with it. So this is your microservice. Mrs. Banker is very good with numbers, so number crunching. So anything that needs to be maybe getting some information about prices or something, Mrs. Banker will deal with it. And the doctor is very good at doctoring images. So Mrs. Banker goes, hey, do you need any number crunching? Can I do any number crunching for you? And the queue goes, yes. Can you update my currency conversions, please? And Mrs. Banker will just deal with this, because this is what Mrs. Banker does. Mr. Postman will do the same. Mr. Postman will just ask, hey, can I have some email messages or SMS messages? And again, a couple of messages go in, and Mr. Postman deals with it. The next one is the doctor. So the doctor takes care of images. The doctor will go, hey, I'm the doctor, because this is all the doctor can say. And it will get some messages as well, and the doctor will deal with those images. So you have a massive layer of abstraction in there, because all your messages are going into the message bus. So none of your applications rely on each other. Granted, you might have a database for this, which could be common for all of them, but there's ways you can sort of not rely on the same database for all of your applications. Now, why not queue? Because I mentioned queuing is a good thing. How about when queuing is not a very good thing? Payments is a good example of you shouldn't queue that, okay? Imagine you go to Amazon.com and you make a purchase, and you want to get immediate feedback because you want to know if your purchase went through, okay? So you want to know if your payments actually went through, right? So payments is not a very good example for queues, because if you add payments into a queue, you will make the user wait for however long it takes for that payments to be processed. So that's not a good example, and it breaks the flow a little bit. So I would say don't break the flow. If it's something that the user relies on getting immediate feedback, then just don't break the flow. My next slide is about feedback. So any kind of feedback that you need to give to the user, don't use queues for that. So if you need to give the user any feedback, queues are not for you. Just use normal HTTP requests and just wait for the transaction to complete. Don't leave me hanging is my words for this. So don't tell the user, hey, I've got another 10,000 items to process, but as soon as I'm done with that, I'll get back to you. So you shouldn't do that. You should, this should be a normal flow. But which one will you choose? There are quite a few different queuing systems out there. I know which one I prefer, and I'll tell you a little bit about them. So Microsoft MQ is a great queuing system by Microsoft if you are a Microsoft developer. So if all you do is Microsoft and you don't really want to do any cross-platform development, Microsoft MQ is very good because it's really well integrated with Microsoft.NET. So you almost get queuing out of the box with Microsoft. So that's a good example if you're using Microsoft, okay? If you're not so much. RNMQ is an example of a hosted queue. So you're not actually hosting the queuing system in-house, you have a hosted queue. So you basically pay RNMQ. I think the website is rn.io. You pay them, and you go, OK, so I'm going to be creating queues here, and it's a RESTful API, and you send your request there. What I don't like about RNMQ is you are adding a lot of extra overhead into your application, because now you rely on an external service, and if it's down, you're in trouble. Redis, does everyone know what Redis is here? Cool, so the way Redis works is Redis is not really meant to be a queuing system. A lot of people use Redis for queuing systems because it's almost like a database. You can add items to it, and you can pull them back. So with queuing, you can pretty much use anything. Redis is not the right solution for me because I think using Redis in your application, if you're not already using it, wouldn't really make sense for queuing. So you can use an application that is fit for purpose. JMS, Java Messaging Service, is good, but again, you fall back into the Microsoft MQ kind of life because you're now only able to use JMS if your applications actually live on the JVM. So if you're a Scala developer, Java developer, or Clojure developer, you will be able to use JMS. The one that is my favorite is RabbitMQ. So RabbitMQ is a completely open source system. It has library wrappers for pretty much every single language you can think of. There's even a Haskell one. And it just works. So you install it, and it just works. You can start using the queues. You can start creating queues. It's a hosted service, so you actually have to host it, which is very good because it gives you control. So if you want to do some clustering, if you want to do backups of your queues, if you want to store your queues wherever you want to store them, then RabbitMQ is a good contender for this. Just the key takeaways here. So just what we just talked about. Communications is hard, OK? So if you go in multi-platform or something, communication will be hard. And queuing is one way to make communications easier, but communications is hard. High traffic is good. OK? So a lot of people go, hey, yeah, my application died because of high traffic. That's not a bad thing. If you're having a lot of traffic, you should be thanking your users for this. Scale, scale, scale. So always think about scalability. Queues will give you the right platform for you to scale your application. Stay away from exceptions. So this goes back to my isolation example. So stay away from them. Isolate your exceptions elsewhere. Make them happen elsewhere. And don't let them break your system. Coding should be fun, OK? So back to the cross-platform thing. Coding should be fun. Use the best tool for the job. Don't just use whatever tool your company forces you to because they think that's the only way your applications can communicate. Queues aren't for everyone. So as I mentioned, if you're doing certain things, don't use queues. They're not for everyone. They're definitely not for payments. So don't use queues for payments. Don't use queues for feedback. And with that, thank you very much. My name is Marcus. I'm a developer evangelist, and I'll be here for both 2 days.
We have time for a few questions about communication APIs. So who already used Twilio? OK, so a few people in the room.
No, I must say, this light is a killer.
What?
Like, this light here is a killer. Like, I'm sweating because the light is like directly on me.
Yeah. So, it's for putting you in stress. Exactly.
Yeah, exactly. You've only got 20 minutes, so you have to live before you die.
Okay. So thank you for the feedback.
Just stay tanned in Barcelona.
Okay.
Yeah.
Yeah. So that's it. So just a question about the use cases you've seen on top of Twilio. Like, what is the most, let's say, surprising use cases you've seen of communication APIs?
You mean specifically on Twilio? Or?
Oh, your communication APIs mainly.
Cool. Well, there's people communicating with all the sorts of things. Like, there's people communicating with the fridges now. There's people like writing code to talk to their fridges. I spoke to this guy who controls his washing machine, so he can actually control when the washing machine is going to turn on, which is kind of cool. But then he also needs to build a robot that will take his laundry into the washing machine, because just controlling the washing machine doesn't really help you that much. So that's one of the things. One of the things I've seen.
So, do you see an Internet of Things trend?
Absolutely.
Yeah.
Yeah, absolutely. It's absolutely massive now. So yeah, 100%.
So yeah, so it's communication APIs for machines more than for humans. This is the trend.
Yeah. So even like what I was talking about here, you are really talking about two systems communicating. So it's not so much to talk to humans. It's very much to talk between things.
And so, last question for my part, but do you see more usage of communication APIs like events, like okay, SMS received or not, like or like or the content of the communication for machines is important, because tomorrow we talk about natural language processing.
Yeah.
So do you see like, for example, you say to the machine like, okay, start at 6:20 because So which is more part? Is more event-driven or content-driven?
I think it's a lot more event-driven. So one of the things about having messages or adding messages anywhere is you want to make sure your messages are very concise. You want to make sure your messages are short and sweet. So you don't want to be passing like massive images into your messages. You want to be passing a reference to an image, but not the bystream of the image or something. So I think making sure the images are small enough and short and sweet is kind of the hotspot in there.
Okay. Oh, one question here.
Hey, thanks. I can imagine a pattern where you want to convert asynchronous into synchronous, maybe by sending the return code or an exception as just another message in a separate queue or a different queue. Is that a useful pattern, or do you think it's just asking for trouble?
Sorry, can you just repeat that?
Certainly. I can imagine sort of wanting to convert an asynchronous service into a synchronous service,
yeah,
maybe by returning a return code or an exception that's just another message. Is that a useful pattern, or do you think it's problematic?
The thing is, your queues, depending on how you actually structure your systems, your queues will be very, very busy most of the time. So I wouldn't really try and convert an asynchronous thing, something that goes into a queue, into a synchronous process, just because your queues will be busy most of the times. And I wouldn't really want to rely on, so I don't really have that many errors on my system, so it's kind of okay. Like, having an error is already a terrible thing. If you're going to make the user wait to get an error, then I wouldn't really, does that answer your question?
Yeah, thanks.
So then what is the alternative if you've got scalability as a problem, which is typically why you do asynchronous, well, one of the reasons why you do asynchronous stuff, and is it just a matter of making a hard decision at the architecture level? Then are you going to force the way the developers develop around this paradigm? Are you going to tell them at first that, no, sorry, you can't do async stuff, it's just not going to work, for very specific purposes? In my mind, I'm thinking the IoT-based protocols like the PubSub MQTT stuff.
Yeah.
By definition, that's a queue in a sense.
It is a
PubSub queue.
Yeah.
So, how do we help the folks building those kind of solutions at the technology level make the right decisions about what not to use, let's say MQTT for?
Yeah, so that's an interesting thing, because I've been talking to many people who claim to be using queues, and a lot of people who use queues, when you ask them like, okay, but why are you using this? And they go, well, we have RabbitMQ installed, so why not just put everything through the queue? And this happens more often than not, okay? So I think it's very much about the architecture. I think it's very much about thinking ahead and thinking about what you're trying to achieve, what you're trying to accomplish. So using queues for everything is ridiculous. You should definitely not start using queues for everything. They're cool, okay? So once you go that path, it's actually very cool when you see things communicating. But you really need to think about where the queue is actually going to act in your favor and when it's not going to act in your favor. So it's there's no right or wrong in there. So I can't really tell you, yeah, do that and you're always going to be on the right path. But I would say the most important thing is think about anything that you can do with fire and forget. So think about anything that you can do with, like, I don't need to give the user any feedback, and it's going to be okay. And if you have that, then that's a good queuing contender. If you have doubts, then take a step back and try to, try and make sure whether you should be using or not queues.
Thank you. Thank you, Marcos. Thank you very much.